And this video will review Section 2, Chapter 9, and 2b. So in moist climates, the water table replenishes the stream. So in this top diagram, rain that falls on the surface flows into the ground via infiltration, enters the zone of saturation, but then since the land level is below the water table, the water flows into the stream. So you can see all these arrows here showing that water is flowing into the stream, so the stream level stays at the height of the water table. So there'll be water in the stream regardless of how much rain falls on the surface. Now on the other hand, in drier climates, the land level sits below the water table. So the water table is only here as water flows in over the land on the surface, fills the stream, and then that water will seep into the ground and the stream will dry up. So in New York, you'll see it in a minute, most of our, if not all of our streams are this type of gaining stream or perennial stream. Some very basic knowledge to remember and not forget. Rivers flow down hills. They do not flow north, south, east, or west. They flow down. Sometimes that's north, sometimes it's south. Please remember that, please. So here we have rivers. Moist climates are perennial, streams that flow year-round. Darker colors show that if it's dark brown, most of the streams there are perennial. So here's New York. So you can see all of New York State except some outlying areas are filled with perennial streams. If we had class and we lived here in Arizona, we'd be dealing with dry streams, streams that are only available with water in them after a heavy rainstorm. And here's a picture of a dry stream, and this video we saw in class of that flooding. You can just search on YouTube for flash floods, and you'll see lots of videos of dry streams filling with water, and then that water draining away. So this is pretty simple, right? The depth of the water table determines a stream's behavior. Humid climates would be perennial, arid climates would be dry. Now with that said, we'll go right into the next little section here, 2A, and we'll see that there is a delay, however, a lag we'll call it, between when the rain falls and when the rivers rise. So this simple little graph shows, as a bar graph, rainfall. So at this point in the day, let's say this is 12 o'clock, if this is 12, there we go, that's when the maximum rain fell. But if you watch the river height would continue to climb until maybe 2 in the afternoon, maybe hours later. If the stream is larger, it might even take longer. It might take several hours before you see the river reach its highest point. So small rivers rise quickly, large rivers rise slowly, and they also then, the flooding goes away slower. So when you're dealing with big rivers, like the Mississippi or the Illinois River, hundreds of miles long, that flooding may last for days. It may last, in this case, this map is from the summer, and it's through Saturday. So they're talking about flooding for days at a time. In little creeks, they rise and fall quicker. So if you take a smaller river, let's pick one in New York here, let's say the Black River here in New York, right, feeds into Lake Ontario. If there's heavy rain in its watershed, more on that later, it will rise very quickly, and then that river will drain very quickly, and it will be short because that river is smaller. If you deal with a major river like the Hudson River is collecting water from all of these side rivers. So these will flood quickly, and then that kind of collective flooding will head to the Hudson, causing the Hudson to rise. So down here in Westchester, the Hudson may rise days later after heavy rains upstate New York. So that's simple, right? The delay between rainfall and flooding. as a quick video on rivers and rainfall.